Hello student, welcome to my lecture videos. So today we will be talking about atoms and elements. If you remember, while discussing the classification of the matters, we briefly talked about elements, which is a example of pure substance. In element, exactly you have only one type of substance. If you look inside in detail, you won't find anything else. It is only one substance, but it needs far more in-depth discussion. So we will be talking about in today's lesson plan these five important topics. So if you look at it, we will be talking about these five topics: elements and atoms, Dalton's atomic theory. Then we'll talk about subatomic particles, that is electron, proton, and neutron, and briefly structure of the atoms. Then we'll talk about ions. Ions are two types, cations and anions. Then we'll talk of the isotopes. And at the end, we will talk about moles and molar mass of the substance. In this case, it is element. This mole and molar mass is also applicable for compounds, which will be discussed in your next chapter. So let's move on. First, talk about what is an element. Element is a class of compound which is available in the nature. It is not man-made, or it is prepared by any chemical reaction. It is a substance which is available in our nature, in our earth surface, in our atmosphere, in a sense. So those elements are made up of something called atoms. Atom is the smallest part of the atom element, and the atoms of the same elements are same, atoms of different elements are the different. But before going into detail of that, so the composition of an element and the concept of atom was put forward by a great chemist whose name is called John Dalton. So John Dalton's atomic theory was the first attempt to explain the composition of an element. And John Dalton's theory, although it is a little bit obsolete, since it was introduced long ago, a lot of development has been done so far, but still that is the backbone of the composition of element. So let's talk about first John Dalton's atomic theory. So let's go to slide number 44, 45. That is the John Dalton's atomic theory. 47, 48. So actually, you will find it in slide number 23 in the PowerPoint slides. John Dalton's atomic theory is this one. There are 4 or 5 postulates depending on how it is presented. But these are pretty simple in today's world when science has developed significantly. But it has to be understood in this particular class as we are starting from the basics of the chemistry. Each element is composed of tiny indestructible particles called atoms. So it means every element you take, for example, iron, cobalt, nickel, oxygen, they are all composed of a very tiny indestructible particles that called atoms. All atoms of a given elements are same in their mass and volume. The atoms of the different elements are different in terms of mass and volume. Atom combines in simple whole number ratios to form compounds. So that will be discussed again in chapter 3 again. So when compound is formed, the elements of different substance or different element combine in a simple ratio. So atoms of one element cannot change to atoms of another element in a chemical reaction, So also you will find, in this John Dalton theory, many of the concepts put forward by John Dalton, they are found to be not true. For example, the first one, that the element is composed of tiny indestructible particles. It is no longer true. Atom can be broken. We can break it and look at inside. That we will explain in a couple of minutes. So you will find most of the postulates or theory put forward by John Dalton have proved to be not entirely correct. They have exceptions. But nonetheless, this John Dalton's atomic theory is the foundation of composition of element. So as you understand that any element you take, this element is a composition or collection of millions of tiny indestructible particles, that is called atoms. Atom looks like a ball or a sphere in a sense. So it is a collection of spheres for a particular element. They are same in size, same in mass. So they are, if we are talking about one element, they are same, but if you are talking about different element, their size and mass will be different. But as I said, where do I find exactly, the list of the elements we know? So if you look at it exactly, you will find the list of the elements are best found out in a chart called periodic table. I hope you know what is called periodic table. We will explain in detail in chapter 9. Also, we will explain it in the later part of this chapter. So if you look at this is periodic table. All the elements are documented here by something called symbol. For example, the element one is called, suppose, carbon. This carbon is represented by a C, that is called symbol. So every element has a symbol and the elements are presented in this periodic table by symbols. For example, we are talking about carbon. This is C. Suppose we are talking about magnesium. This is Mg. So every element known to us is documented or listed in the periodic table by their atomic, the symbol in a sense. And that symbol sometimes one letter or sometimes it is more than one letter in a sense. So this is called periodic table. We will explain the details of the periodic table in a separate video. So if you look at each of the elements which are listed here and listed by a symbol, we have to learn each element is composed of their own atom and what is inside present in that atom. For example, if you look at it, this element called beryllium. If you look at this element Be, beryllium, it has a number 4 on the top and there is a number which is on the bottom, but it is not here. So we will show you in a separate periodic table. You will find there will be a number close to called, I will say 9, that is called atomic weight. So let's go a different periodic table and then. So look at it, suppose I'm talking about a particular element, and if you look at these particular elements, so you will find in the periodic table, an element has two numbers, one on the top and one on the bottom. That is, chromium has 24, and there is a number on the bottom that's called 52, and that is called atomic weight. So if you look at this one, in that case, you will find that the number on the top, this is called atomic number, and number on the bottom is called atomic weight. And these two numbers will tell you very important things about the number of subatomic particles. So before we move on to the subatomic particles, what I'm trying to say, Every element in the periodic table is represented by a symbol, and it has two numbers, one on the top and one on the bottom. But the number on the top is called atomic number. In case of a chromium, it is 24. In case of a titanium or Ti, it is 22. And the number on the bottoms are called atomic weight. These two numbers will tell you how to find out the number of subatomic particles, and also we will explain what is subatomic particle. So, let's go back and discuss the subatomic particles that actually we are going to talk about it. Okay. So if you look at the subatomic particles, as we talked in the beginning, if you look at it, atom of an element looks like a ball. If you draw this in a two-dimensional structure, it will look like a circle. So if you look at this particular, the atom of a particular element, there is a center. And in this particular inside the atom, it is like a ball. And as we explained in terms of Dalton's atomic theory, it was indestructible. So it cannot be broken, but that's not true. Eventually, we found the atom can be broken. So if you broke it and look it inside, every element atoms are composed by three subatomic particles: electron, proton, neutron, and electrons. So this is represented by a small p, neutrons is n, and electron is e. Okay? So the mass of the electron, proton, and neutrons are given. We'll talk about it. So the very first thing that we need to know, each element has how many electron, proton, and neutron. We will discuss the nature of the electron, proton, and neutron in a minute. But before that, these are the three subatomic particles. Since they are present inside an atom, they are called subatomic. So every atom of an element composed of electron, proton, and neutron. You will see there is only one exception. Hydrogen has only proton and electron, no neutron. But in all other elements, all three subatomic particles are present. So now we will try to find out how many electron, proton, and neutron is there in a particular element. For example, few minutes ago we were talking about chromium. It was 24 and 52. Okay. So if you look at it, then in this case, this is called atomic number. And this is called atomic weight. Sometimes, you will find atomic weight is not a whole number. Sometimes it is a fraction. Suppose I say it will be 52, but look at the periodic table in your textbook. Suppose it is 0.02. If that is this one, you round up to the nearest whole number, that is 52, and that will be called as mass number. So let me clarify. The number on the top is called atomic number. The number on the bottom is called atomic weight. If the atomic weight is not whole number, which is in most of the cases, they are fraction. So round up to the nearest whole number, that is called mass number. This atomic number is equal to number of electron and proton. The number of electron and proton are equal to atomic number. That's same, and there is no exception. So how many electron and proton is there in chromium? Each of them are 24. Okay. And how many neutrons are there? Neutron will be mass number minus atomic number. So it will be 52 minus 24. So it will be 28. So this is the way you calculate the number of electron, proton, and neutron present in an atom. Okay. So let's solve one more problem. Then suppose we are talking about beryllium. It was 4 and it was 9. This is the mass number. So number of electron and proton is 4 and neutron will be 9 minus 4 is equal to 5. So in case of a beryllium, it has 4 electron, 4 proton, and 5 neutron. So this is the way you can calculate, find out the number of electron, proton, and neutron in an atom, and you will find the proton and neutron of an atom are present inside that very small dot, which is called nucleus. Okay? All the proton and neutron of an atom is present in the center, which is in small place, and we say that his name is nucleus, and the nucleus contain all the proton. And if you are talking about beryllium, then it has 4 proton, 5 neutron, and all the electrons are present outside of the nucleus, and they are revolving, they constantly move. But for the timing, we will say, just we are talking about the distribution of electron, proton, and neutron. Proton and neutron is inside the nucleus, electrons are outside. They keep revolving. More discussion will happen in chapter 9 when we talk about electronic distribution. So this is the way you take any element from the periodic table and do some homework and try to find out number of electron, proton, and neutron. And the number of proton and neutron are inside the nucleus, electrons are outside, they keep on moving. Now we will move on to the next part. What is the properties and characteristics of the subatomic particles, electron, proton, and neutron? So if you look at these electron, proton, and neutron, these 3 subatomic particles, their mass is given in kilogram. The mass itself is very small. If you look at it, proton 1.67262, 10 to the power minus 27 kilogram, and 1.67493, 10 to the power minus 27. So if you look at it, the mass of the proton and neutron are pretty close, although they are pretty less because it's 10 to the power minus 7 kilogram. But in case of an electron, if you find it is 0.00091 10 to the power minus 27. So if you compare, although the mass of the electron, proton, and neutron all are small, but if you compare their mass, electron is far, far lighter compared to proton and neutron. Actually, electron is around 850 times lighter compared to proton and neutron. You must be thinking that, the mass is always small, nonetheless, proton, neutron, and electron. Then why they are given in kilogram? Because kilogram is the SI unit of mass. That is the reason it is given in that. But you look at it, this number, if someone asks you, what is the mass of an electron, proton, and neutron? You have to memorize these long number into the 10 to the power minus 27 in terms. It is not easy to remember. So that's why we created a different unit called AMU. What is AMU stands for? It is called Atomic Mass Unit. This is called AMU. This is a unit to express the mass of the subatomic particle as well as mass of the atoms and molecules, because their mass is so small. The conventional unit of the mass like gram, kilogram, or microgram even, or picogram is not even good enough. So that's why we created a mass unit to express the mass of the atomic unit, the atomic atoms and molecules and subatomic particle. If you look at it, mass of the proton is 1.00727. In case of a neutron, 1.00866. And in case of an electron, it is 0.00055. So for all practical purpose, mass of proton is considered to be 1 and neutron 1. It is almost, we say, 0 or insignificant. So comparatively, so mass of a proton and neutrons are considered to be same, and that is 1 AMU. And in case of electron, don't say it is 0, sometimes it is relevant, but it is insignificant or close to it. Similarly, if you look at their charges, there are two type of charges, from electricity. One is positive and one is negative. So proton has one unit positive charge and electron has one unit negative charge, plus one and minus one. It is relative unit. And neutron is neutral. It has no charge. That's why it is zero. So you may be thinking, what is that plus one and minus one? There is no unit to it. It is a relative unit. Actually, the actual charge is in coulomb. That is the unit of charge, 1.60218 10 to the power minus 19 coulomb. It is so small, again, instead of memorizing that charge of a proton and electron in terms of coulomb, we have given a number plus one and minus one. But actually the real term is that number we read 1.60218 10 to the power minus 19 coulomb. That is the actual charge. But in case of a proton and electron, they are exactly same and opposite. So if you put one proton and one electron together, the charge will be zero. So proton and neutron, since their charge is same, if you put them together, their charge will be zero. Okay, so you understand a atom of a element is composed of electron, proton, and neutron. You know how to find out number of electron, proton, and neutron from the atomic number and atomic mass, which you can find out from the periodic table. Also, you know the characteristics of the electron, proton, and neutron. What is their mass? What is their charges? These are very important and you must memorize it. If you cannot remember, proton is positively charged and it has one unit positive charge, your progress in this class will be significantly slowed down. So please memorize how to find out electron, proton, and neutron, their charges and mass. That is absolutely fundamental for this class. Now we will move on to something called ions. So now we will be talking about ions. Few minutes ago, I was telling you any atom of an element is actually neutral. It has no charge. So suppose you are talking about carbon. So if you look at carbon, it has 6 and 12 cc atomic number. 12 is the mass number. So it has 6 electron, 6 proton, and it has 6 neutrons. Why 6 neutron? 12 minus 6. So since 6 electron has minus 6 charge, because each one has minus 1, 6 of them is minus 6. 6 proton is plus 6. And neutron has no charge. Together it is 0. Minus 6 plus 6 is 0. So every atom of an element is neutral in charge. Why? The charge of the proton and charge of the electron cancel out. So that's why atom as such is neutral. But if an atom lose or gain electron, it becomes ions. So a ions is produced by loss or gain of an electron, and if it is losing an electron, if it is lose an electron, then it becomes positively charged. That is called cation. For example, sodium 1 plus, that's a cation. If a negatively charged, this is called anion. So ions are of two types, cations or anions. How they are produced? Both by either loss or gain of an electron. So let's talk about how ions are produced. So ions are produced by loss or gain of electron. And there are two types. So there is called cation, which is positively charged, and it is anion. It is negatively charged. So it could be plus 1, it could be plus 2, plus 3. So cation is produced by loss of electron from atom. Anion is just opposite, is produced by gain of electron. So for example, sodium, if you lose one electron, if one electron is taken out, it becomes sodium 1 plus. Since electron is 1 minus, exactly the charge balance, it is 0. The charge balance is maintained, but since one electron is lost, one positive charge is developed over sodium, that is Na plus, and it is called sodium cation. Similarly, if you take calcium, it has also 0 charge, calcium atom. It lose 2 electron and become calcium plus 2. Again, plus 2 and electron 2 minus, because 1 minus 1 electron, 2 electron is 2 minus, together it is 0. So these Na plus, calcium 2 plus, they are called sodium ion, calcium ion, or calcium cation. So you may be thinking, if it is, can produce plus 1, plus 2, can it produce plus 3, plus 4? Yes. There are only 3 types of cation is possible. It is plus 1, plus 2, and plus 3. Similarly, in anion, the anions are produced by gain of electron. For example, in case of a fluorine, if it gain 1 electron, then it will be 1 minus. Similarly, if it is oxygen, if it gain 2 electron, it will be O2 minus. This is called fluorine anion, and it will oxygen anion, or even in case of a nitrogen, if it gains the electron, it is nitrogen 3 minus. So anion can be also minus 1, minus 2, minus 3. So let me summarize first. Ions are 2 types, cation or anion. They are produced by loss or gain of an electron from a neutral atom. Cation is produced by loss of electron, and in case of anion, it is produced by gain of electron. If it lose 1 electron, it will be plus 1. If it is lose 2 electron, it will be 2 plus. Similarly, if it gain 1 electron, it will be 1 minus. If it gained 2 electron, 2 minus. In case of a nitrogen, or elements which gain 3 electron, it will be 3 minus. So you may be thinking then, every element can produce any type of ion? No. Although there are 3 types of ion we are talking about, plus 1, plus 2, plus 3, minus 1, minus 2, minus 3. Elements has a preference that what type of ion it is going to produce, whether it is produce cation or anion. Those discussion will come in appropriate time when we discuss about the periodic table. Okay. So not that every element can produce any type of ion. Every element has a preference to produce a specific kind of ion, and that is dependent on their properties and their electronic structure. That will be discussed in appropriate time. Okay. So actually, in this particular uh, chapter, there is a list which element produce what type of ion. So let me show you that. So if you look at this one, group 1 elements, lithium 1, sodium 1, these are the type of ions elements supposed to produce. Aluminum plus 3, nitrogen 3 minus, phosphorus 3 minus. So you understand every element has a specific type of fascination towards an ion. For example, sodium produce plus 1, magnesium plus 2. We will explain all these things in when we discuss about the periodic table in a separate slide. Okay. Now we will be talking about something called isotopes. So when we discussed about, the Dalton's atomic theory, we said the atoms of the same elements are same in terms of mass and volume. Atoms of the different elements are different. But actually, there are certain cases when this particular concept is not correct. The atoms of the same element can be sometimes slightly different, and they are called isotopes. So what is isotopes? Isotopes is called the atoms of the same element. So we will talk about the isotopes. Actually, it's called uh, isotopes are atoms of the same element having same atomic number but different mass number or atomic mass. Actually, atomic mass and atomic weight are same. Okay? So that exactly is the definition of isotopes. So if you look at it, suppose I will tell you a few examples here and then we will generalize based on that. For example, in case of a carbon, carbon has 6 and 12. And there is another carbon which is called 6 and 13. And there is another is called 6 and 13. If you look at carbon has three different type of atoms which are the same atomic number, all six. But their atomic weight is different, or actually we are writing this, it is called mass number, different. So if the atoms of the same element have same atomic number, but they have different mass number, they are called isotope to one another. So carbon has three isotopes. Okay? And if you look at it, having the different mass number, it creates a very unique circumstances. If you count the number of electron, proton, and neutron to all of them, you will find it will be 6, 6, and in this case, number of neutron will be 6, say 12 minus 6. So it will be 6. But in this case, it will be 6, 6, 7. And in this case, it will be 6, 6, 8. So if you look at it, in the case of the atoms which constitute the isotopes, they have different number of neutrons, 6, 7, and 8. So in most of the elements, there are more than 2 or 3 isotopes is always present. And you will find in these isotopes, the number of electron protons are same, but number of neutrons are different. That's why they have different mass, but their charges are same in a sense. So exactly you will find the isotopes are present in uh, all elements. So in this class, you do not have to study all of them. But before we move on to the examples of other isotopes for different element, so one question to be answered, is all these three isotopes are present in same proportion? No. In naturally occurring carbon, you will find one isotope will be present in a very, very high number, very, very high number. And the others are present in relatively less quantity. For example, I will say what percentage they are present. You will read your textbook for exact percentage, but I will say somewhere it will be 98.5% or 6% is one isotope. That is this isotope. And probably this one is 1.4%, or I'm just giving a rough number, and this one is 0.1%. So it means if you take 100 carbon atoms, only you will find one or two are other than carbon 12, carbon 13, or carbon 14. Sorry, this is a wrong number. It will be 14. Sorry, this will be 14. So if you look at it, one isotope which is present in a large quantity and rest of them are present in a very small quantity, and that isotopes is normally known as normal. If you ask what is the atomic number and atomic mass of carbon, everybody will say 6 and 12. They are referring to the normal isotopes which is present in a large quantity. In addition, having all those different percentages, it creates something that's called the weighted average atomic weight. weighted average atomic weight. So actually, that is calculated based on like 12 multiplied by 98.5, that is the percentage of abundance, plus 13 into 1.4 over 100, and then it will be 14 into 0.1 10 to the power by 100. So if you add them together, whatever it comes, that is the atomic weight you see in the periodic table, or it is atomic mass. So the atomic mass you see in the periodic table is the weighted average of the atomic weight of all the isotopes. That's why it is most cases it is a fraction. It is not a whole number in essence. So every element has one or more isotopes, not one, I would say two or three or more isotopes, and they differ in their mass number. As a result, they have different number of neutron, but same number of electron and proton. And since the isotopes have different number of neutrons, so their mass is different. So that actually influence the average mass of the element that we report in the periodic table. So I will give you a few examples in this particular chapter that will be really helpful. You don't remember all the isotopes, whatever is possible. For example, I will say chlorine has two isotopes, 1735 and chlorine 1737. Actually, this was approximately 75%. This is 25%. In case of a hydrogen, it has three isotopes, sorry, 1 and 1, hydrogen 1 and 2, and this is hydrogen 1 and 3. Okay. So I exactly don't remember the percentage looked in the textbook. So this one will be again almost 99%, and this one will be somewhere together will be 1%. Okay. So if you look at it, this is the only element which has no neutron, because hydrogen 1 has one electron, one proton, neutron is 0. But in this case, it will be 1 and 1, it will be 1, 1 and 2. So these are the isotopes. Sometimes they are called D, sometimes it is called it has a different name, sometimes it's called deuterium, tritium. Deuterium, tritium. Look at the spelling from the textbook. So in case of oxygen, it has two isotopes, 8 and 16 and 8 and 17. Okay. So this is what exactly the isotopes. Isotopes are atoms of the same element, but they have different atomic mass, resulting to different number of neutrons. Now the question is that if the isotopes are slightly different, what is their difference in their properties? Actually, you will find the isotopes are or isotopes of an element have similar chemical properties. But slightly different physical properties. Like mass, density, etc. Okay. Also, I'll tell you one more thing we should remember. So when you write isotopes, it is written in many different ways. For example, carbon is written as 612, 613, 614. They are also written sometimes like this one. Carbon 12, carbon 13, carbon 14. We just don't write the 6 because the atomic numbers are same. Sometimes isotopes of carbon is written like this one. Sometimes also it is written just like this one, 12, 13, and 14. Okay. So before I move on to another topic, one particular inconsistencies we have in writing that I need to explain it to you. So you have seen in the periodic table, whenever the atomic mass and atomic number is written, we write it like this one. For example, we write 6 and 12, sorry. So, we write like this one, 6 and 12. This is the atomic number. And this is atomic weight. This is good in a periodic table. The atomic number is written on the upper part and atomic weight is in the bottom. But when we write as a teacher or as a student in anywhere else outside of the periodic table, in your answer sheet, notebooks, you will write in a slightly different. You have to write it like this one. Atomic number in the lower part, like a denominator, and 12 on the upper part, and it is written on a little bit on the left hand side. So instead of writing right like this one, rather we like it is slightly on the left hand side. Actually, why it is written like this one, I don't know. This is the way it has been for generations. So whenever you write or I write the atomic number and atomic mass in anywhere outside of the periodic table, atomic number will be on the bottom and the atomic weight will be, or mass number will be on the little bit on the left hand side. Okay. So we now understand the atomic number, atomic weight, we understand ions, we understand isotopes. And before I conclude today, there will be one more thing to ask. And we have to know it fairly well, which will also be discussed in your subsequent videos. For example, as I said, that you have to know something called atomic weight, uh, and I will say uh, something called mole. And these two concepts are very, very important. What is atomic weight? We have seen in the periodic table, the number on the bottom is called atomic weight. For example, in case of a carbon, if it is written like this one, 6, and probably it is 12.01, look at your periodic table. This is called your atomic weight. And it has no unit. Mind it. It is just number 12.01. Okay. When you convert this one into gram, so I say 12.01 gram, then it is a mole. So 1 mole of carbon is called 12.01 gram. So in case of a magnesium, suppose it is 12, it is 24.3, it is written in the periodic table. So you will take 1 mole of magnesium is equal to 24.3 gram. Okay. So sometimes even we sometimes say 1 mole of any substance is equal to the atomic number expressed in gram, that is called 1 mole. This mole concept has enormous implication in general chemistry, and we will explain this one in detail when we solve numerical problems. So how do you find out 1 mole of the substance of any element from the periodic table? Take its atomic weight and just attach grams. Carbon atomic weight 12.01, 1 mole of carbon is equal to 12.01. 1 mole of magnesium is 24.3 gram. Why? 24 is the atomic weight. Okay. So these two concepts are very, very important that we need to understand. We will continue to do. So this is what, let me see whether we have discussed everything we talked about. Yes, we talked about the elements, subatomic particles, and all the 5 things that we plan to discuss. One more thing I will discuss, and rather I will ask you to study. So you didn't really, I will say, if you don't get surprised, I will be really, really surprised myself. So when I say, that element is composed of electron, proton, and neutron, so all these things are not discovered by imagination or in anybody's dream. Those things was discovered by different scientists, great scientists, and they have done it over a period of a long time by doing or performing tedious experiments. So I will give you an responsibility there to read the textbook and find out 2 things. Who are the scientists who discovered electron, proton, and neutron? Okay, so you will find out from the textbook. It is very simple. The name of the scientist, name of the scientist, who discovered existence of electron, proton, and neutron. You will be surprised. Just find out the name. It is available in your textbook, in your these PowerPoint slides. And second, find out the name of experiment, scientific experiment that helped to identify the presence of electron, proton, and neutron. So there are 2 things. The name of the scientist who discovered the subatomic particle and what experiments they have done. And in your higher class, those experiments will be discussed in detail. Probably it is in your textbook, but I will say it is not necessary to study the details. Sometimes it is a little bit time consuming, and also I will tell you, maybe it is not the appropriate time to explain since we are starting from the very fundamental level. Okay, this is all about an electron, proton, and neutron.